So TubeTech has loaned me a complete mono setup so I can dip my toes into the world of mono imaging. And there'll be a review video coming on that equipment as well soon. So I've been experimenting with different ways of processing both LRGB and narrowband data within Siril. And one of the first things that I wanted to tackle was replacing the stars in a narrowband image with RGB stars. And if you've been shooting in mono for any length of time, you're probably aware of the issue, right? So if you're shooting in narrowband, your stars generally come out all magenta. So it's an easy enough fix where you can like desaturate them, just make them, turn them white, process them externally, and then put them back into the image. And that's fine and it's acceptable. But I wanted to get the colors of the stars that we can get from an RGB session into the narrowband data that I took on any given night. And the process has been around for a while. It's not anything that I've come up with myself. But again, I wanted to come up with a workflow to allow us to do this within Siril. So that's what this video is about, adding RGB stars into your narrowband data so you can maintain both the details that you get from shooting a narrowband as well as the colors that you get from shooting with broadband. A couple things before we get started. This is not going to be a how to stack video. I already have a previous video on how to stack your mono data. So we're going to be starting with my 6 raw channel stacks, one for red, green, blue, sulfur 2, hydrogen alpha, and oxygen 3. So that is our starting point. Also, I'm going to be using a handful of Python scripts throughout the workflow. So if you're not familiar with any of them, I do have videos on how to use each of them, and I'll leave links to those in the description below. So let's get started. This is going to be a fun one. My name is Rich, and you're watching Deep Space Astro. Okay, so these are my 6 stacks. You can see I have R, G, and B, as well as HA, O3, and S2. And all 6 of these stacks I have in a stacks directory. You can see the path right here. So on my D drive, under Sessions, RedCat 51, Cygnus Wall, and then stacks. So I'm going to go back up to the Cygnus Wall directory, and I'm going to create a working directory for myself. And I'm just going to call it working. You can name it whatever you want, that's fine. We're going to come over into Siril and we're going to set our working directory to that directory that we just created. So D drive, Sessions, RedCat, Cygnus Wall, and working. Click open, and you can see up top here my working directory is set to my working directory. So the first thing that we need to do is make sure that we have all 6 of these images, all 6 of these stacks aligned perfectly together. So we do that by coming up to image processing, under composition, and then RGB compositing. And we're going to assign all 6 of these stacks to their own layer within the composition tool. At this point, we're not actually creating a composition, so it doesn't matter in what order that you load these into, and it doesn't matter which color is assigned to them, and I'll show you that in a minute. But just to keep things in order in my mind, I'm going to go RGB first, so we'll put the R image, which is in my Cygnus Wall, under stacks, into the red channel, and we'll go and grab the green image for the green channel and blue for the blue channel. Then I'm going to hit my plus button to create a 4th layer, and even though it's yellow, that's fine. Like I said, it doesn't matter at this point. And we'll add sulfur 2 to that layer. We'll create a 5th layer, and we'll assign HA, and then a 6th layer, and we'll assign our oxygen 3. And at this point, you're probably thinking, Rich, what the hell are you doing? This image looks like crap. We don't care. We're not saving this. We're not actually creating a composition right now. We're using this tool so we can do our alignment. So to get a better view of what we're looking at, we're in linear right now. So let's go into auto stretch and then also unlink the auto stretch. And at least we can see the data now that's in the image. You can also see, the rotation between the different images, indicating nothing is lined up, right? So that's going to be our first step. We're going to come down here in the bottom, and we have an alignment method and a framing method. The defaults are fine for what we're going to do, but just to show you what options are available, Deep Sky, like it says, is a 2-step global star registration. And that's what we will be using, but I just wanted to show you, if you're doing some kind of planetary work, you have the DFT and the combat options available, as well as a manual alignment. Now, we're not going to be using the manual alignment, but just to talk about it real quick, these boxes under X alignment, Y alignment, and rotation, you can see they're grayed out. There's nothing we can do with them. When we do execute the align command, you'll see in these boxes where it made these adjustments, both in X, Y, as well as the rotation. So it's just for informational purposes. But if you wanted to do this manually or maybe tweak the automated process after it completed, you could come down into the alignment method, change it to manual, and now you can see all these boxes become available. So just for awareness, so you know how to access the manual settings if need be. Again, we're going to run it in Deep Sky. The next option is our framing method. We have 3 to choose from. We have first channel, minimum, and COG, center of gravity. First channel just means it's going to align all these images with our first channel, which in this instance would be the red. Minimum is about the minimum framing, so it'll minimize the amount of artifacts, if you will, that we would see around the edges. And then the last one, and the one we're going to be using, is center of gravity. So it'll keep everything centered based on the pixels right where we want it to be. So with all that being said, we're using the defaults. Simply going to click the align button. And if you watch the image, you'll see everything will snap right into place. All of our stars are nicely aligned. If we look up in the corners, you can see that the images have all been rotated during the alignment. And this is the part of the image that we will be cropping out. Which brings us to the next point, is cropping. So we've done the alignment, and we've done the alignment so when we extract the RGB stars from our RGB composition that we're going to be creating, and we add them into our narrowband image, we want the stars to be in the correct location, right? Even being off by just a few pixels, you do a plate solve and things will be tagged in the wrong area of the image. It's just not correct. Now we need to be able to crop all 6 of these images, and the crop needs to be the same across all 6. The reason we do that is because at the end of this workflow, when we bring the RGB stars into our SHO image, if those 2 images are not the same dimensions, the star recomposition tool will not work. It will not allow you to load images of different dimensions. So we need to make sure that A, everything is aligned, and B, everything is cropped to the same dimensions. Now, with that being said, just to explain the process, the image composition tool actually creates an internal sequence. And when I say internal sequence, I'm not talking about what we're used to seeing over here on the sequence tab. If I click my search sequences button, it just takes me right back to the console and it shows me there's no sequence found. Instead, what happens when we click the align button, if we go back over into our working directory, it created another directory called cache. Within that are some text files labeled internal sequence 0 through 5, each one representing one of our 6 images that we loaded into the tool. You can open them up. Like I said, they're just ASCII text files, and shows you the settings that it used during that alignment process. So you don't need to be concerned with this. You don't want to change anything in these files. Leave them as they are. But this is the internal sequence that it created. And because it created an internal sequence, what that allows us to do is I can come over and I can draw a selection specifying the areas that I want to crop of the image. And then right click, crop. And instead of hitting crop, we're going to say crop sequence. And now that crop has just been applied to all 6 of these images that we have loaded inside of the tool. Now, to be able to use those, we just click the Save All button. Clicking the Save All button, again, if we go back into our working directory, we have 6 new files now. All of them prefixed with comp underscore, so all of these images are now aligned together with the same crop applied to each of them. So that's all we need the tool for in this step of the process. We're going to use it to create our compositions, but that's all I was saying. We don't care about the colors. You can come in here and you can change them, you know, and just play around with them. You can see the effect it has on the actual image. But again, we're not actually going to use this composite. We're ready to create our RGB composite right now so we can rip the stars out. So we're just going to come over and we're going to hit the clear button and it resets everything back to square one. So again, let's start with the RGB. So in the red channel, I'm going to specify my comp underscore red file. Green, I'm going to hit the green file. And blue, we're going to grab the blue file. If we link our auto stretch, that is what our linked stretch looks like. So we're going to leave that link so we can actually see what we're doing as we're going through this process. And I'm going to click the linear match button, and it's going to do a linear match for the green and blue channel to the red channel. The adjust layers brightness comes into play when you have more than 3 layers, when you're doing an RGB like we are now, or 4 if you're including the luminance. So it's not going to have an effect. And actually, if I click adjust layer brightness, and then come over to the console, you can see in the bottom it says nothing to adjust, no overflow. So just so you know what it's for, it's if you had multiple layers that you were trying to composite together, then this may bring some value to you. The sum exposure time, this has no effect on the actual image itself. It will write information into the headers. And if you hover over the tooltip, it shows you, it'll create a value in the fits header of the final stack called stack count, which will show you the number of frames that it stacked, as well as write a value to the live time keyword, which is your total exposure time in seconds. So I'd leave it ticked. It's a nice piece of information to have in the fits header. Your color composition types are over here, so it defaults to HSL. You can also do HSV or CIE lab. I have a very minimal understanding of color theory, but changing these, at least on this image, has no effect on the composition that we're working with. But just so you're aware, you should be fine with the HSL. All right, so with that being said, we're going to click close, and that's our RGB composite. So we're going to do some processing with it. No stretching. It's going to remain in its linear state because we're just looking to steal the stars out of it. So the first thing I'm going to do, because this is not a save file yet, is I'm going to save it. So we'll click our save button up top here, and I'm just going to call this RGB 32-bit fit. We're going to get a warning because we're still in linear. That's fine. Click save anyways. And then we're going to do a background extraction. Now, it's up to you which background extraction tool you want to use. It doesn't matter. Whichever one you like using, whichever one you feel gives you the best results, it's fine. Our three options as of time of recording are you can come up in the image processing and use Siril's background extraction, or you can use one of the two Python scripts that we have under processing. We have Auto BGE, or you can use the Graxpert AI for your background extraction. I'm going to use the Auto BGE, but like I said, it's up to you which background extraction tool you want to use. I'm going to leave the default settings and just hit process. And once that's complete, I'll close the script. And then we'll come up to Tools and Astrometry and Image Plate Solver, so we can plate solve the image in preparation for color calibration. As usual, all my information is in here. It's being pulled from the FITS header. So I'm going to click OK. And then we're going to come over into Image Processing, Color Calibration, and Spectrometric Photo Color Calibration. We're set to mono. I'm going to untick narrowband because I use my TubeTech RGB filters for this particular set. And click OK. All right, we'll get rid of our white balance summary, close SPCC, and now we are fully color corrected. Next thing I'm going to do is come up into scripts, Python scripts, processing, and then sharpen. Now, since all we're interested in this RGB stack is the stars, there's no sense in wasting any time processing in non-stellar. So I'm going to leave it in stellar only, and for this image, I'm going to back down the stellar amount to about 0.3 and click apply. Once that process completes, close the script, and then again, we're going to come up in the scripts, Python scripts, processing, and cosmic clarity denoise. We're going to set it to full, and I'm just going to leave it at the default 0.5. Click apply. All right, now that denoising is complete, we can close that script, and now we're just going to remove the stars. So we'll come up to image processing, star processing, and then StarNet star removal. Just make sure pre-stretch linear image is selected, as well as generate star mask, and click execute. All right, so stars are gone. We are obviously looking at our starless image. And if we come over into our working directory, and you don't have to do this, I like to do it just so I don't get turned around. Like I said, this is the RGB stack that we're just after the stars for. So I don't need the starless image. I'm not going to use it for anything. So I'm just going to delete that, and that'll leave me just with my star mask. So now we need to build our narrowband image. So we're going to go back up into image processing, composition again, and then RGB compositing. Close the current image. And this time in the red channel, we're going to assign our comp S2 file. In green, we're going to do HA. And in blue, we're going to do our O3. Again, come down to our auto stretch view, and we're going to unlink it so we can see everything. We're going to apply a linear match to this one as well, and close. This one I'm going to save as SHO, 32-bit floating point, and our warning about the image still being linear, which we know, so save anyway. And now we have our SHO composite to work with. I'm going to come back down. I'm going to link my auto stretch view, then our background extraction. Same thing as the RGB. It's your choice which background extraction tool you want to use. I'm going to use scripts, Python scripts, processing, and Auto BGE once more. Default settings work well for this one as well. Hit process. Close once it's complete. And then we're going to go Tools, Astrometry, Image Plate Solver again for color correction, and click OK. Once it's plate solved, image processing, color calibration, SPCC. This time I'm going to tick my narrowband mode. These are the SH&O filters that I use, 6.5 nanometer. Click OK. Close the white balance summary and then close the tool itself. And this is our SHO, right? We always expect to see all the green because we're assigning the hydrogen alpha data to the green channel of the image. And it's perfectly fine to leave it that way if that's the look that you're going for. But I think generally when somebody is building the iconic SHO Hubble Palette, they remove the green from that image You get the blues, they get the golds and the yellows. It's more eye appealing than just all the green. You want to go down that path. You want to come up to image processing, color calibration, and then color calibration again. And this is the manual color calibration, right? So we need to set a background reference, find some place. This image is kind of tough because there's a lot going on in it, but just find an area of the background, draw a selection around it. Under background reference, click use current selection. And then for the white reference, we're just going to draw a decent size selection that captures some of the dark areas, the bright areas. It has some contrast all within that box. And then click use current selection on the bottom. And then we're going to click apply and close when it's done. So that is more of the SHO palette look that we're going for this tutorial. Next is we want to do some sharpening to this one as well. So scripts, Python scripts, processing, and then cosmic clarity sharpen. And we're going to do the opposite with the SHO image that we did with the RGB image, in the sense that we're not interested in the stars in our narrowband data because we're bringing over the RGB stars eventually. We just want to sharpen the non-stellar. So just to save time, we're going to select non-stellar only. And I'm going to bump this up to 0.7 for this non-stellar amount. And I'm going to take the strength up to about 5. Your settings will vary depending on your data, and then click apply. When sharpening is complete, we're going to click close, and then we're going to do some denoising. So we're going to come up into scripts, Python scripts, processing, cosmic clarity denoise. Again, you can use Grexpert as well if that's what you prefer. Set it to full, 0.5 works, and click apply. Click close when the denoising is complete. And now we're going to remove the stars. So image processing, star processing, StarNet star removal. And this time, since we don't need the stars from this image, we're going to unselect generate star mask. Just make sure pre-stretch linear image is selected and hit execute. Okay, so the stars have been removed. Now we're ready to start processing our starless narrowband data. So we're going to come out of auto stretch and go back into a linear view. And we're going to start with another one of the Python scripts. So we'll come up to scripts, Python scripts, processing, and statistical stretch. This is just a first initial stretch. It does a pretty decent job as a good starting point, but we will fine tune it just a little bit more using GHS here afterwards. We want to select a link stretch, normalize, and I'm not going to tick the curves adjustment. We'll do that manually. So click apply and then close when it's done. And you can see our visualization sliders, at least in this case, the top one's all the way to the right. The bottom one's moved over a little bit, so I'm going to put that back over into the left. And then we're going to come up into image processing and stretches and generalized hyperbolic stretch. And the first thing I'm going to do is make a black point adjustment. You can see the data for the histogram is off the left edge of the screen here. So we're going to change our type of stretch to linear stretch and just bump that back over. And then click apply. We'll come back up into generalized hyperbolic again, and I'm going to select a relatively bright area in the image and set that as my symmetry point. And then just stretch a little bit more, trying to get the image a little bit more, to have a little bit more contrast in it. Every time you click apply, your symmetry point gets reset. So if you're doing small iterations like I am here, make sure you hit your eyedropper button again. And then once again, we'll do a little bit more of a stretch. I'm just going to grab a faint area of the image up here, set that as my symmetry point, and that should brighten things up just a little bit. I'm going to go too crazy with it. And I think I'm happy with that. And like I said before, we're going to do some curves on it. So image processing, stretches, and then curves. Just pull down the darks just a little bit. Bring up the highlights. You can do a preview for before and after. Yeah, and I think that looks good. I'm not going to do too much more with that, but obviously tweak it to your liking. Close when you're happy with it. Now we're going to remove green noise. And removing the green noise, I can see a little bit of a green cast in the image. So removing the green noise will give our golds a little bit more pop, our blue a little bit more pop. So just up in image processing and remove green noise. Average neutral is fine. Click apply, and you've probably seen that if you watch along the wall here. If I undo it, that's before and that's after, so that looks a lot better. The other thing that I'm seeing that I don't like about this image is there's a lot of magenta in there. It's taking away from that SHO look that I'm going for, so I want to remove all this magenta. So what we're going to do is come up to image processing, negative transformation, and then run a remove green noise again, because green is the opposite of magenta. So when the image is inverted, it's removing the magenta when I use the remove green tool. So image processing, remove green noise, click apply, and then close. And then we're just going to re-invert the image again. So image processing, negative transformation, and that looks a lot better. At this point, one of the filters that I like to use sometimes, and I always run it against my data just to see what it looks like. I don't always like it, but sometimes it does add a nice amount of contrast to the image. It's up here in image processing and filters, and it is the contrast limited adaptive histogram equalization. Default, it comes in with a grid size of 8, and you have a preview button here so you can unselect it. That's before, that's after, and just play around with the different grid sizes to see the effect that it has on the image, to see if it lands on something that I think looks good. Most of the time it does. Sometimes it gets crazy like this, and there's just no good setting for it. So it's just playing around with the grid sizes. Yeah, I think 14, I mean, it's taking our colors down, but we should be able to bump that up with some saturation. So let's try that. I'm going to leave it at a 14 grid size and hit apply. And then we'll come up into image processing and color saturation. And we'll start with global and see what that gets us. Yeah, see, that's bringing back what we lost, but we still have all that contrast that the other tool brought in for us. So that's before, that's after. I like it. We'll hit apply and keep that. Now we're just going to put the stars back in. Before doing so, we want to make sure that we save this image. And then come up into image processing, star recomposition. Close the image when it prompts you, that's fine. And then in our background side here, we're going to open up the star list that we were just working on. And on the star side, we're going to grab our RGB star mask that we extracted previously. Move this over to the side so we can see what we're doing. I tend to click the advanced button down here so I can see all the settings. Color stretch model, human and even weighted, generally will do better with star colors. I'm going to leave it in the modified arc sign transform and then just start stretching it, right? As much as you want. I've shown this before. You can go really crazy with this. We just want to bring the stars in to your liking. So I'm going to say that looks good. Click apply, click close. And if you want to get real fancy, we can use one more script, and that's up in our scripts, Python scripts, utility, and the signature tool. And I'm just going to slap my logo down in the corner for this one. I already have a profile set up. So bottom right selected, apply signature, close it when we're done. Last thing to do is to make sure you save your composition because it is not in a saved file right now. So we'll come up to the save as, and we're just going to call this Cygnus Wall. 32-bit floating is good and done. At this point, you can also save it off as a TIFF or a JPEG for posting on social media. Choice is yours, but that's the final product right there. All right, so I hope that's useful for anybody that was looking for a workflow and how to do this within Siril. I plan on having other videos around mono processing now that I have a mono setup. Like I said, TubeTech loaned it to me, but more than likely I'm going to end up purchasing it because I'm really enjoying the whole mono side of things. I want to take this time to say thanks to all my members, not only here on YouTube, but also on Buy Me a Coffee. I appreciate each and every one of you. Thanks to everybody who's made donations. Thanks to everybody who has purchased the beginner's guide. Link in the description for that if you haven't seen it. Please consider subscribing if you're not already a subscriber. Leave a comment, share the video, all that stuff, all that interaction helps with the algorithm, which in turn helps with keeping the channel going. Once again, thanks for everybody's time. I appreciate all of you. See you in the next one, and clear skies.